Hello everyone, welcome to Electronic System Design Laboratory 2. In this video, we'll see the first experiment, which is the study of ARM evaluation system. So the aim is to study the hardware platform provided by the evaluation system of NXP2148 ARM and the on-chip peripheral function of the LPC2148 microcontroller. So now let's see the kit, okay, and see the various functions of the ARM kit. This is the top view of the ARM microcontroller kit. So now let's see one by one what are the various functions available which we can use for our experiments. So here, as we can see, these are the 8 data lines. Okay, so D0 to D7, and also there are three other date switches available over here. Okay, so it is reset, read, write, and enable ports, and this is the LCD display. So connections made from this port to LCD can be used for displaying information. So from this port we can make connections to the LCD pins so that we can view the display over here. So here we'll get two lines of display. Okay, in this LCD screen we can actually see two lines of display, and it can display up to 16 characters, like displaying the real-time clock, or also we can display character or string. So next we have the 4x4 keypad matrix. Here actually we have 16 push buttons. Okay, so we can use in our experiments. So here you can see 4 rows and 4 columns, and you have control pins over here. Okay, 4 row and 4 column control pins, and we can assign them to the corresponding port so that whichever key is getting pressed over here, it will be displayed in the hyperterminal window. Okay, so next you can see the interrupt. Okay, so here the interrupt ports, they are used for studying the external interrupt, and we have the two switches over here, okay, for providing it external interrupts over here to verify any operations. So next we have the 7 segment display. Okay, so here we have 4 digit 7 segment display. Next you have extra switches. Okay, these are the switch interfaces. So we have 8 switches over here. So it is for providing interface like memory read write or erase operation. We can use these switches. So this is the power supply. So here you can give either AC or DC 12 volt power supply, and this is the on off switch. We can provide power to the ARM kit. So this is the mic available over here. So here you can give any input through this, any analog signal input through this mic. So here you have the UART cable, okay, through which you will be downloading the cable from the PC. Here you have the switch. Okay, either it will be in program mode or execution mode. Okay, so while downloading the program from our system, we will be keeping the switch in program mode, and when we want to view the output, okay, after dumping the program into the kit, and we want to view the corresponding output, maybe it may be a LED output, or we need to display some LCD over here, or we need to hear the buzzer sound or something, whatever output we need to check using this ARM controller, you can push this button to execution mode and press this reset button over here. So once you push the button to execution mode and press the reset button, you can view the corresponding output in the respective ports over here. Okay. So these are the basic functions. Okay. Now here you have the buzzer interface available over here. It is driven by NPN transistor. The base of transistor is connected to port 25, and apart from that you can see the relay also over here. Okay, you have the relay interface also over here. So there are two 5-volt relays which are connected to port 30 as well as port 10. So next you have the I squared C interfaces. Okay, it is I squared C RTC interface and I squared C EPROM interface. So here it provides onboard to study the I squared C interface. In general, the I squared C interface is a communication protocol. It uses two bidirectional data lines for communicating with microcontroller. So now, whichever device is I squared C compatible, when it is incorporated on this on-chip interface, it allows direct communication between those two devices. Okay, in general, it uses this master-slave method for communication. Then next you have the analog variable analog voltage source to be used in any experiment in which we are dealing with analog to digital conversion, and it connects to port 29. Okay, it connects to port 29, and it also has a potentiometer which can be used to adjust the input voltage which we are supplying. Also this board has the temperature sensor which whose output is linearly proportional to Celsius temperature. So next we have this stepper motor interface over here. So this is a unipolar stepper motor which is connected on board for any experimental purpose. So this is the most common functionalities which we can use in most of our experiments, and especially in the following experiments which we will be using in our lab classes. Thank you.